In examples 3 and 4, we'll find the partial derivative of a given function with respect to a specific variable, calculate the derivative function, evaluate the derivative function at a specific pair of values, and then interpret that result. In example 3, we have a local company that spends X thousands of dollars a year on online advertising and Y $1,000 on mailings and brochures. The total cost of advertising in thousands of dollars is given by this function C of xy. We want to use Symbolab to find the first partial derivative with respect to x and then with respect to y. In order to do that, we'll make use of these input values that they give us. And as we swipe through those, depending on the device you're using, these tabs will look different, these tiles will look different, but we're looking for that delta over delta x notation. And then we want to input the function that we're differentiating. And once we hit go or enter, we'll evaluate and we get that first partial derivative as 6.7738x. If instead we wanted to evaluate the first partial derivative with respect to y, when we press that delta over delta x, automatically it's differentiating with respect to x. But if we tap or click or mouse over into that delta over delta x notation, we can delete that x and replace it with a y or whatever other variable we want to differentiate with respect to. And then click go or enter, and we get 8.9812. In part B, then we're asked to evaluate c sub y, that first partial derivative with respect to y, at this given xy pair. C sub y, that first partial derivative, has no variables in it, so regardless of what our x and y values are, this result will be 8.9812. We'll note real quickly here that we ended up with a positive result for our derivative function, and we were differentiating with respect to y. So when we look at part C to interpret this result, also keeping in mind that our values are in thousands, x is in thousands, y is in thousands of dollars, and the total cost of advertising is in thousands of dollars, meaning we have to multiply each of our values times 1,000. We can say that when the company is spending $11,013.50 on advertising and $29,988 on mailings and brochures, then the cost will increase by $8,981.20 if the amount spent on, since we're differentiating with respect to y, if the amount spent on mailings and brochures is increased by 1 unit, which in this case is $1,000. Since those y values are in thousands of dollars. In example 4, we have a company that produces 2 versions of a particular product. The function below gives the total revenue and total cost of producing and selling X low-end versions of the product and Y high-end versions of the product. We're asked in part A to find the profit function P of X, and then in part B to find P sub x, that first partial derivative with respect to x. Keeping in mind that profit is equal to revenue minus cost, the first thing that we need to do in Symbolab is take the difference of these two functions I'll subtract the cost function in a set of parentheses to make sure that subtraction carries through to each term. And we get our like terms combined to get this simplified profit function. Now, to evaluate that profit function, to evaluate the first derivative with respect to x, we'll select that delta over delta x notation. We'll enter our profit function. And we'll evaluate that to get 0.06y plus 124 minus 0.14x. In part C, we're asked to evaluate that function for a pair of values, x equal to 1,487, y equal to 1,876. So we would evaluate our function from part B, that derivative function, for these two values, and we would get 28.38. Note that that result is positive, which tells us that when we're selling 1,487 units of the low-end version of the product, and 1,876 units of the high-end version of the product, the profit will increase since that resulting derivative value is positive, and that rate of increase will be by approximately $28.38 per unit increase in the production of the low-end version of the product. And we know it's the low-end version that should be increasing because we differentiated with respect to x, meaning we keep y as a constant value.